All right, to add on to 15.4, which was measures of dispersion, we're going to talk about variance and standard deviation. So, used to be, years ago, we had to calculate the standard deviation by hand. You would take the data values minus the mean, square them, sum them, divide by the total number of values. It was a long process. Now we can use the calculator. So let's calculate the standard deviation using the calculator. You might want to refer back to the notes from 15.2 and 3 and that talk about how to clear lists and how to enter the values into your calculator. So this is really what I'm using. Okay, so let's get that calculator up. I'm going to go back to Stat and Edit, and I'm going to clear out my lists. Remember, don't hit Delete. All right, and then I'm going to enter those grades. All right, so there should be 8 of them, and there are. So I'm going to go to Stat, Calc, 1-bar Stats, and I need to tell it L1. Remember, if you have the other kind of operating system, the newer one, in the frequency you'd have nothing. And then we calculate that. So we have two standard deviations here. One is an S with an X, and the other one's like that circle, omega X, and they're both, one is for the sample. We talked about a sample as like a, just a smaller amount of data values from a larger whole, and the population one would represent the entire population. That's the omega X one. So let's see, I would be thinking that these grades would be representing maybe a sample, so 5.83. Okay, so the variance, what is the variance? The variance is the square of the deviation of each data value from the mean divided by the number of data values. So the formula for variance is 1 over n times the sum from 1 to n of the data value, which is x sub I, minus the mean squared. So basically, to figure out this variance, the variance is just the standard deviation squared. So if I take 5.83 and square it, it's 33.9889. That's supposed to be an 8. Okay, so these are other measures of dispersion as well, and they actually measure how spread out the data is maybe a little bit better than the range or the interquartile range or the mean or the median. So find the variance of grades on a test, and here are the grades. All we need to really do is find the standard deviation. Okay, so if we go back into our calculator and we again enter that in, we would have 84, 97, 92, 88, 79, and in L2, 12786. Alright, then you go to Stat, Calc, 1-bar Stats, but this time you need to put something in the frequency list, and we need to do L1, L2, and there we go. So again, I would think that these would be a population because it'd be all the grades on a test. So I'm going to go with the 5.66 value. and the variance is just the standard deviation squared. So 5.66 squared, 32.0356. Okay. So let's take a look down here. So standard deviation. The variance is not as useful as standard deviation because it's in square units. If the data were a set of measures in feet, the variance is in feet squared. Standard deviation, you just take the square root of the variance and units are the same again. So the standard deviation equals the square root of the variance, and the variance was equal to the standard deviation squared, which we already established. So standard deviation of a population is again explained versus standard deviation of a sample. So find the standard deviation and variance number of online friends of 10 students in a high school. So again, we can just enter that into the calculator. And I would think that this would best be represented by a sample. So you would be using the SX from the calculator, which becomes 4.4969. So the standard deviation is that value, 4.4969, and the variance is that value squared. So if we square that, it's about 4.4969 squared. It's like 20.222. And there are other decimals as well. It didn't say what to round to, so I just went out to 3 decimals. The next one, stem and leaf plot, asks you to enter the data and find the mean, median, mode, variance, and standard deviation. So again, I would just tell you into L1 and L2. I'll start a couple of them. I would have, 21, 22, 24, 25, 26, and so on and so forth. And then in L2, I'd put the frequency of those. I think that would go a lot faster than having to type in all those different 25s and 26s. So there's 121, there's 122, there's 420, there's 2 24s, 425s, and 526s, and etc. All right, so when you enter that, and then you calculate it in your calculator, the mean is 34.73. The median is also in there, is 31. The mode, you need to just look at the list and count which ones occur most. So if you look at, I think here, I think that some of these numbers have changed a little bit. Maybe the 9. Yeah, some of these values looks like they've changed a little bit. So the mode, I think that one occurs most often. 1, 2, 3, 4, 5, 6, 7, 8 times. Are there any others that occur more than that? I don't think so. So the mode would be 29. And if you did a standard deviation, this would be a population, I would believe, so about 11.8177, and the variance would be that squared, which is about 139.658. Okay? Again, the next one, enter the data into your graphing calculator, the ages of students in a history class, find the variance and standard deviation. So now you would do the same exact thing. And one last one, because it's a little bit easier to enter, a little bit faster. Again, clear, so then 18, 17, 16, and 15, and 1, 5, 10, 10. And then stat, calc, 1 bar stats, You have to tell it second L1, comma, second L2, enter, and we would probably want it says all the students in a history, so I'd want the population was 0.847. So the standard deviation, 0.847. And the variance would be that squared, so that's about 0.717409. Okay? So that's basically what you do there. Now we're going to see next time what we're actually going to do with those things.